Hi there, my name is Nupinder. Now I'm going to explaining the coolant system on my 2014 Honda Civic. First, I'm now going to mention all the coolant related parts. So this is the upper radiator hose. This is the thermostat housing, inlet for the water pump. So the water pump is down there. There's the water pump pulley. So this is inlet and outlet for the heater cores. So the both heater core hoses coming down here, and this is coolant hose going to the transmission here to cool down the transmission fluid. So now I'm explaining the coolant flow. So I'm starting with the water pump. So there's an inlet for the water pump. So water pump take the coolant from the inlet hose and push to the cylinder walls, and from the cylinder walls coolant goes up to the cylinder head, and from the cylinder head the hot coolant goes to the heater core inlet. So from the heater core inlet, the coolant coming from the outlet from the heater core and coming back in the thermostat housing. So if the engine is not warm yet, the thermostat stay closed, and the bypass on the Honda engine, there is no visible bypass hose. It's the internal part of the thermostat housing. So when the engine is not warm, so coolant coming from the heater core going in the thermostat housing, and again from the thermostat housing, from the bypass route, the coolant goes into the water pump inlet. The bottom radiator hose connected to the thermostat. When the coolant temperature high enough to open up the thermostat gets open, and the cold coolant coming from the bottom radiator hose go into the thermostat housing and go to the inlet for the water pump, and the water pump suck all the cool coolant and push to the cylinder walls. Again from the cylinder walls coolant goes to the cylinder head and get into the heater core, turn to the thermostat housing again. So there is a coolant used for another purpose too. So this coolant hose go into throttle body. There's an inlet for the throttle body, there's an outlet to cool down the throttle body while engine is running, and this is inlet for the transmission. There's a transmission cooler down there, and there's the outlet for the transmission fluid coolant. So here is the thermo fan and the AC condenser fan. There's a shroud, the coolant temperature sensor. So here is the coolant temperature sensor and the bottom radiator hose. So now I'm going to explaining the wiring diagram of thermo fan and AC condenser fan on Honda. So Honda use 4 relays for controlling thermo fan and the AC condenser fan. So the thermo fan is relay controlled by the PCM. Then the PCM turn on the 35 and 36 circuit. 30 and 37 connects, and power goes to from the pantry to the thermo fan motor, and from the ground side the power goes to the fan control relay. So on the normal condition, the ground from the thermo fan goes to the 30 terminal. That's a 5-point relay, and from the 30 power goes to 37A, and all the way down give power to the AC condenser fan and to the ground. So if I jump 30 and 37A on the thermo fan relay, it's gonna turn on both thermo fan and AC condenser fan at the same time, because they both are connected in the series. If the 30 and 30A connect in the fan control relay. So if I want to turn on the thermo fan, first I have to jump 30 and 37A, then power goes to the thermo fan, and after that I have to remove the fan control relay. After removing the fan control relay, so I'm gonna jump 30 to 37, because the 37 is goes to the ground. So when I do this, the power goes to the 30 to 37A, go to thermo fan motor, go back to the relay, and goes to the ground. So after that, when I do this, the only thermo fan will turn on. Here is the I removed the thermo fan relay. So I already jumped 30 and 37. So here's 30 and 37. Now I'm going to jump. I already removed that. There's a the fan control relay. I already removed the relay. So after that, I'm gonna turn on, jump the 30 and 37 to give ground to the thermo fan. So here I'm going to give ground to the thermo motor. If I give ground to the 30 to 37A, the both motor gonna connect in the series and the both motors gonna turn on. Thank you. Now I'm going to showing the common leaking points. So the coolant commonly can be leaked from the hose clamps, and also could be leaking from the water pump. The beep hole for that water pump is very down. If you see the coolant coming from the beep hole, it means the water pump is not good. And also the common leak could be found for the coolant from the radiator. So here is my coolant diagram for my 2014 Honda Civic. So if the thermostat is seized shut, it means the thermostat is closed. So the coolant goes to the water pump, to the cylinder wall, cylinder head, go through the heater hose inlet, out from the heater hose, and goes to the thermostat housing. But because of the thermostat is shut, it go back to the water pump. So if the thermostat is shut, it's gonna increase the engine coolant temperature. It could be, the engine could be overheated because there is no path to go to the radiator hose. If the thermostat is open, the coolant goes to the water pump, go to the cylinder walls and to the cylinder head. So if the heater core is on, some of the coolant go to the heater core and go back to the thermostat housing, and the hot coolant go to the upper top radiator hose, cool down in the radiator and go back to the thermostat housing. So if the thermostat is seized open, so the engine not gonna operate on their operating temperature. So engine always gonna run on the cold temperature, and it's gonna increase the fuel consumption. So if the thermostat is seized slightly open, it means the thermostat is open very little bit. The coolant from the water pump goes in the cylinder valves and to the cylinder head. If the heater core is open, the hot coolant goes in the heater core and come back into the thermostat housing, and the hot coolant from the engine cylinder head goes in the radiator through the top radiator hose and go, after cool down, go back in the thermostat housing. So if this in that condition, if the outer temperature is too high, there is some chances to get the engine overheated because there is no enough flow of coolant from the radiator because the thermostat is not open completely. If the outer temperature is too low, so it can have a chance to engine to run under temperature, so it's going to increase the fuel consumption. So if the VW plastic water pump impeller not turning, how we can check? So if the water pump is not working, it means there is no flow here, there's no flow of coolant, so it's going to create the engine overheating. We can check in the temperature gauge. Or another thing, if the impeller is not turning, it makes the grinding noise or beeping noise from the pump. So we can check if there's noise, then there is a problem with the pump. Radiator and the heater core both working on the convection method. It's liquid to air cold method. So when the hot coolant coming from the outer hose goes in the radiator from the fins, the air from the atmosphere run through all the fins with the fan, and it take out all the heat from the coolant, and the cold coolant go out from the bottom radiator hose.